Hello and welcome, fellow students. Today we are going to continue with the iterations over trees. We are going to see the preorder, inorder, and postorder traversals. And to complete these exercises, as always, I will start sharing my screen. So let me check the controls here. And here it is. So let's continue where we stopped the last day. Today we are going to work with this tree, with this binary tree. And just a quick reminder, we have the preorder traversal. Remember that the prefix in the algorithm name tells us the order where we process the root of the tree, right? So for instance, here in the preorder, the root is processed at the beginning. In order, the root is processed in the middle. And in post-order traversal, the root is processed at the end after iterating over the left branch and iterating over the right branch. Right, so let's start with the first tree and the first order. So here with preorder, we process the root at the beginning. So the first thing that we do is to print, in this case, to process or to print the content of the root, right? So we start in A, and as I said, as we process the root, we start with the root. Then we iterate over the left branch, so we go to B, and here we start again, and we process the root, right? So the root now is B. We process B, we continue, and we iterate over the left branch, so we go to F, and in F we process the root, which in this case is F. Again, we are done with the root, so we iterate over the left branch. Here we don't have left branch, so we don't have anything to do. We iterate over the right branch of F, and we don't have it neither. So we are done with F. We have processed the root, we have iterated over the left branch, and we have iterated over the right branch, which doesn't exist. Once that we are done with F, we go back to B, and in B we have already processed the root, and we have iterated over the left branch. Now we need to iterate over the right branch, and here we don't have right branch, right? So we are done also with B. Again, we go back to A, and we are done with the left branch. So we need to process the right branch, right? So we move to C, and in C, we process the root. This is the first thing to do, process the root, which is C, and then we iterate over the left branch. So we move to D, and in D, we process the root. This is the first thing to do. Again, we are done with the root. We process the left branch, which doesn't exist here. So we iterate over the right branch. We go to G. In G, we process the root. Every time that we enter a new node, we need to do these 3 steps from the beginning, right? So in G, we process the root, which is G in this case. We iterate over the left branch, so we go to I, and here we process the root. Right, so we write I. In I, we iterate over the left branch, which doesn't exist. We iterate over the right branch, which doesn't exist. So we are done with I. We come back to G. In G, we have done the root, and we have done the left branch. So we iterate over the right branch, which is J in this case. In J, we process the root. First step of the algorithm, we process the root. We go to the left branch, doesn't exist. We go to the right branch, which doesn't exist. So we go back to G. We are done with G. We have done the root, the left and the right branches, so we are done. And we go back to D. In D, it's the same. We have processed the root, the left branch, and the right branch, so we go back to C. In C, we have done the left branch, and we have done the root, so we move to the right branch. We are in E, we process the root, and we iterate over the left branch, which doesn't exist. So we iterate over the right branch, which in this case is 8. We process the root. In H, we don't have left branch, we don't have right branch, so we move back to E. Here we are done with E. We have already done the 3 steps on E, so we come back to C. Once that we are in C, we realize that we have already processed the root, we have done the left branch, we have done the right branch, so we move back to A. And once that we are in A, we are done the left branch, we are done the right branch, and we have processed the root. So that's all for the preorder iterator, right? And this is the result of iterating over these 3 in preorder. As we mentioned yesterday, if we take this path, you will see that it follows the same order that we have in the definition of the algorithm, right? So in the first place, we have the root. Then we have the left branch. And then we have the right branch. But this is also true if we take any of these branches and we apply the concept, the definition of the algorithm recursively. So here, for instance, we have the root of this branch, which is C. We have the left sub-branch, which consists on these 4 elements. And we have the right sub-branch, which consists on these 2 elements. Right, so doing it like this, you can verify that your path is correct according to the algorithm. You just need to follow to check if the individual components of this path follow this definition with regards to these 3, right? If we can identify the root, the left branch, and the right branch in the same order as it is defined in the algorithm recursively. Okay, so let's go to the next order, in order, and remember that now we process the root in the middle, right? First, we need to treat the left branch and then the root. So we start on the root of the tree as always, and we iterate over the left branch. So we move to B. We start on B, and again, we iterate over the left branch, which is F. We start on F, and we iterate over the left branch. In this case, the left branch is empty, right? So we have done this already, and now we process the root. So the first element now is F. Once that we are done with the left branch and the root, we iterate over the right branch, which is empty here. So we go back. Okay, we have done left branch, we have processed the root, and we have done right branch. So we go back to B. On B, we have already done the left branch, this first step, so we process the root. And we add B to the path. We iterate over the right branch, which is empty here, so we go back to A. On A, we are done with the left branch, so we process the root, which is A in this case. And we iterate over the right branch, so we go to C. On C, we iterate over the left branch, which is D. So we move to D. And on D again, we iterate over the left branch. As we don't have left branch here, we process the root, which is D. And then we iterate over the right branch. So we move to G. On G, we iterate over the left branch, which is I. And when we are here on I, we iterate again over the left branch, which doesn't exist, so we process the root. Right, we write I, and we go back to G. On G, we have done already the left branch, so we process the root. Once that the root is done, we iterate over the right branch, which is J. On J, we iterate over the left branch, which doesn't exist. We process the root. And then we iterate over the right branch, which neither exists. So we go back to G. When we are on G, we realize that we are done because we have done the left branch, we have done the root, and we have done the right branch. So we go back to D. On D, we are also done. We have done the left, the root, and the right. So we go back to C. When we reach C, we are already done with its left branch. So we process the root, which in this case is C. And then we iterate over the right branch, which is E. On E, we iterate over the left branch, which doesn't exist here. So we process the root. And then we move to the right branch, which is H. On H, we iterate over the left branch, doesn't exist. So we process the root, which is H. And then we iterate over the right branch, which neither exists. So we go back to E. On E, we are done. We have done all the process, left branch, root, right branch. So we go back to C. On C, we have done left branch, root, and right branch. So we go back to A. And when we reach the root again, we realize that we have done the left branch, we have done the right branch, and we have also done the root. So by consequence, we have finished with the in-order traversal. Now let's verify that these nodes are in this order, in order. So let's check that the root is in the middle, right? The root is here. And then we have the left branch, and then we have the right branch. And if we go to the right branch, again, we have the root of the right branch in the middle. And we have here the left sub-branch, and we have the right sub-branch. Okay, so that means that this iteration is correct. We should verify it until we reach the leaves, but this is just to give you an idea of how you could check the correctness of these solutions. And finally, let's go to the post-order iterator. So now we process the root in the last place. So we start in A, we iterate to the left branch, we go again over the left branch, and we reach F. And here we iterate over the left branch, which doesn't exist. We go to the right branch, which neither exists. And finally, we process the root. Right, so we start by F. Then we move back to B. We have done already the left branch. The right branch doesn't exist. So we print the root, which is B in this case. We go back, go back to the main root of the tree, to A. We have done already the left branch, so we need to iterate over the right branch, right? So we move to C. On C, we iterate over the left branch, so we move to D. On D, we need to iterate over the left branch, which doesn't exist. So we iterate over the right branch, and we move to G. On G, we need to iterate over the left branch, which is I. So we move to I. It doesn't have left branch. It doesn't have right branch. So we process the root. So we write it as the next element in the traverse. We have done I already. We go back to G. And now we need to iterate over the right branch. So we move to J. On J, we don't have left branch. We don't have right branch. So we process the root, which is J. We move back to the parent, and we have done the left branch. We have done the right branch, and we need to process the root, which is now G. Again, we move back to D. We have done the left branch. We have done the right branch. So we process the root, right? We print D. Again, we go back to C, and we have done the left branch of C. We move to the right branch, right? We have done this step on C, so we proceed to the next, which is to move to E. On E, we need to iterate over the left branch, which doesn't exist, and then we need to move to the right branch, which is H. On H, we don't have left branch, we don't have right branch, neither, so we process the root, which is H. Now we move back to E, and we are done with the left branch of E. We are done with the right branch, so we process the root, which is E. Again, we move back to C, and we have done the left branch. We have done the right branch, so we print C. We move back to A, and we have done the left branch. We have done the right branch, so we print A. And this is the post-order traversal. Again, we verify the correctness of this solution. Now the root should be at the end of the path. So as you can see, now the A is at the end, which is the root. Then we have the right subtree. And at the beginning, we have the left subtree, right? Exactly as the same order that we have defined in the definition of this algorithm, iteration, or traverse. If we take the right subtree, we can verify also its correctness, right? And as you can see, the root is at the end of the tree. We have the right subtree, which is here. And we have the left subtree. So with this, you have another example of iteration over binary trees. Okay, I will stop sharing my screen now. Thank you for joining me today. In the next exercise, we will continue with working on the last tree that we have here. So we will still see more examples about iterations or traversals over binary trees. So stick around and see you next day.